Alright, so here's part B. So we're gonna do what I said. We're gonna start with a equilateral triangle. And we're just gonna call the area X. So step 1, X. I probably need a little more room, so I'm not gonna write the word step every time. This is gonna be, step 2 is gonna be X plus something. So, can you tell me what you do to make step 2?
Well, you split each side of the triangle into 3 parts, and then on the third part you add an equilateral, on the middle part you add an equilateral triangle. It's equal to the length of, its lengths are equal to the length of the third part, the middle.
So, compared to X, what's the area of one of these equilateral triangles?
It's 1/9 of X.
Okay. Why is that?
So yeah,
Because the side lengths are 1/3
Uh-huh.
of X. And area, since you have 1/3 of X, so the side lengths are 1/3, so 1/3 times 1/3, which is 1/9.
Okay. So we have so what you're saying, you're making a geometric argument saying that these are similar triangles to the big triangle.
Yep.
And the side length is 1/3 as long, and area scales by the square.
Of the sides.
So 1/3 times 1/3 is 1/9. And what's a different way we could see
well, you
that
can,
this is 1/9?
well, these, so you could kind of look at it in an alternate way. So these should kind of connect to be a triangle.
Yeah, you're right, they should, but I didn't draw it very well. Okay, let's pretend.
And then, so like then these are all gonna be the same on
Yeah.
the outside.
Good.
So, and then on the inside, they'll fold in.
Uh-huh.
So the inner part is like that, and then we add on these.
Yeah.
So it's the big triangle is split into 9 small triangles, which are equal to these triangles.
That's right.
And so their area is going to be 1/9 X.
Okay, so how much area did I add on total?
You added 1/3.
Yeah, 1/3 of X. I added 3 1/9. So the first step, I add on 1/3 of X. Okay?
Okay.
Now let's see if we can figure out what happens on step 3. How much area do we add on?
So the triangles are going to be, here you're chopping the thirds into thirds, so the triangle sides are going to be 1/9.
Yeah?
That means the triangle's area are going to be 1/81
Okay.
of our big triangle.
And you can
And-
do the same process.
How many of them are there? There's going to be 12.
Okay.
So 12/81, which is,
Well, we can even just say 12/81 if you want, or...
well, I think I can simplify it, so it's 4/27.
Okay, so it's X plus 1/3 X plus 4/27.
X.
Okay.
No real pattern yet that I can see.
No real pattern yet, so let's go to step 4. And I'm not going to draw it all the way around, but I'll just draw it on this side.
So the triangles are gonna be 1/27. Their sides are gonna be 1/27.
Yeah?
Which means their area is gonna be 1/27
So
squared.
729.
Yeah, well, I won't even multiply it out. Let's say it's 1/27 times 1/27. And how many of them do we have?
So we're gonna have 48 of them. Because there's 16 on this side.
Okay. So times 4 times 12.
Times 12. Can't
Or
really simplify.
She was 3 times 16, but
it was what?
I did 3 times 16. Because there's 16 on this side.
Okay.
You could cancel the 3, I guess.
So it's 4 times 4 times 3. Alright, if you want to look at it that way. And previously, when we added this 4/27, this was actually 4 times 3/81 times X. So here we get X plus 1/3 X
I guess
plus
this was
4 times 3.
this was here, it was 3/9.
Yeah. 4 times 3, I'll go back to that in a minute. 4 times 3 over 81 plus 4 times 3 over 27 times 27. Okay. So what do you think's happening each time?
Well, the number you're adding seems to be getting smaller and smaller.
Sure
like-
does.
The third is 27 over 81.
Uh-huh.
You're adding about half that.
Okay.
So that's going, well,
So this-
if you do this for infinity, you'll get a weird infinite series thing.
You will get a weird infinite series thing. There's no doubt about that. And we're going to just try to figure out what that is. If we can figure out a formula for what we're adding on at these steps, then we can crack the code. But first we got to figure out what this formula is, what's going on. So I'm just going to break it into the next one.